Okay, guys, we're going to go over this review. I'm not sure that I'm going to be able to get it in one video, but we'll see what we can do. All right, so for chapter 8, I've listed out some of the vocabulary and terms that you guys need to know. A couple that I just sort of want to point out again, like isotope and where's ion? Did I not put ion? Okay, let's add that. Ion. That's funny. Those are a couple that you kind of need to know the difference between. Maybe ion is over here in chapter 9. No. Okay. So just remember that an isotope is like something that has different numbers of neutrons. So for instance, hydrogen, if you were having like hydrogen 1, then that means that you could also write it like this. Hydrogen's always 1 on the periodic table. And then the mass number would be 1 in this situation. So if you had like hydrogen 2, you would write it like this. Okay? And this number right here indicates the mass number, not the protons. So if it has different numbers of neutrons, then it's an isotope. Okay. So ions are like when we did the build an atom simulation, say we have like lithium, for example. Lithium is number 3 on the periodic table. So that means that it has 3 protons. If you look at it, if you look at lithium on the periodic table right now, it looks like this. It's like 6.947 or something. And so that sort of rounds to 7, which means that it would have around 4 neutrons. And remember that only 2 can go in that first energy level. So it would really kind of want to kick that off of there. So the ion of lithium would be Li+. And you should know that by looking at your periodic table because lithium's in the first group. So everything in the first group is a plus, right? And then everything in the second group is 2+, and then you skip over to like the group that aluminum is in, and it's like 3+. Then you get into the nonmetals, and the nonmetals are going to be the negative ions. So, keep ion on that list. Not really sure why that's not on there. Oops. All right. So the number 1 says, how much energy is needed to move an electron in a hydrogen atom from n equals 2 to n equals 6. So I don't have all of these equations with me, unfortunately. I do have the reference page, so I just downloaded that. If you go to the files on my Canvas, it should have a chapter 8 and 9 reference page. So this will be a good thing to look at to study. So for this one, you're going to need this information right here. So let me see if I can bring up both of these things actually. When I start doing stuff like this, you know how things go for me. I always have the issues. Okay, so it was like this. Okay, and it wants us to figure out how much energy is needed to move an electron from n equals 2 to n equals 3, or 6. So n equals 6 is this negative 6.05 times 10 to the negative 20th minus the low, so this 5.44 times 10 to the negative 19th. Okay. And it's really not having us do anything with the Planck's constant or frequency in this. This is all about just finding the energy. So if you do negative 6.05 times 10 to the negative 20th plus 5.44 times 10 to the negative 19th, should take about 4.8 times 10 to the negative 19th joules of energy to move from n equals 2 to n equals 6. Okay, so now, okay, this is the one that needs this equation. So if it just wants the energy, like on number 1, it's just sort of that. Now this one wants you to find frequency, so you have to rearrange to solve for frequency. All right, so you got to go from the high again, and it was the same, so n equals 6 to n equals 2. So you have this again. And then divided by a Planck's constant, which is 6.63 times 10 to the negative 34 joules times seconds. And so let me see what that is. You guys hopefully can be typing this in the same time as me and see if you guys are getting the right answers, because these are the hardest ones as far as I think on this test, because it's, you know, dealing with these crazy exponents. And this will be in hertz. So 7.29 times 10 to the 14th hertz. Okay? All right. So, I don't think that I ever put a periodic table, unfortunately, on the files. So I'm going to have to Google one here really quick for this next part. This one is wanting us to do the electron configuration. So you guys get out your periodic tables. I will pull up my one on Google here. Boron is number 5 on the periodic table, so got 5 here. And so all you have to do, let me get rid of this guy real quick. Just go through the periodic table, start at the top. So the top group, or sorry, the top period is 1, and then you have to go through the S block, and you go through 2 of those elements. Then you're in period 2, S2, and then 2P1. Aluminum is number 13, so we gotta basically go through the same ones, and we go through 2P, all of those, 2P6, and then 3S2, and then 3P1. Potassium is number 19. So 1S2, 2S2, 2P6, 3S2, 3P6. So what is that? That's 18, and then 4S1. Okay. So remember, if I give you an example, like let's say I gave you cobalt. Cobalt is number 27. You have to do it a little bit different. You go 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, and then 3D. Let's see, what is that? 1, 2, 3, 4, 5, 6, yeah. Or 7. Yeah. So whenever you get to the D block, you have to do one less than that. Okay? All right. Now, it looks like I forgot to fill out some of some of this paper. So it's a good thing that we are going through it on here, huh? Let me just sort of make up some of these isotopes really quick. So let's do C14. Let's do like that. And let me do one more. Okay, let's try this. So how many protons does carbon have? Carbon has, it's number 6, right? So it has 6 protons. How many electrons does it have? 6. How many neutrons does it have? Since this is 14, you would have to have 8. Okay. Oxygen, it has 8 protons. It's the atomic number there. 8 electrons. And how many neutrons does it have? You take that number minus that number, so 10. For bromine 37, bromine is number 35 on the periodic table. Oh, I didn't mean to put bromine 37. I meant to put bromine 82. Okay, so bromine is number 35. But then you take 82 minus 35, which is 47 for your neutrons. Remember, this number plus this number equals this number. Okay, as far as nitrogen is concerned, that's number 7. So it has 7 protons, 7 electrons, and then it would have to have 8 neutrons in order to be nitrogen 15. Okay? All right. So then we got to fill in this table. So I'm going to come up with something again. Sorry, guys. I'm killing it, as always. Okay, let's see. Let's do, whoops. I don't know why it's zooming in. There we go. Let's see. All right, that was my son if you heard him. Okay. Let's do 29 and 34. Why did I skip one? I have no idea. Let's do like that. Okay, so how many protons does calcium have? So look at the periodic table. It's number 20. So that means it's got 20 electrons. If it's calcium 40, how many neutrons does it have? Well, it has to have 20, right? And its atomic number is the same number as its protons. These 3 numbers are the same. And then the mass number is just the protons plus neutrons, so 40. Okay. For the second one, it's number 17. So it's got 17 protons, 17 electrons, and then that would mean that it would have a mass number then of 35. So you can write the isotope a couple of ways. If you look at number 17 on the periodic table, it's fluorine, right? So you can write it kind of like the one above. So it would be chlorine 35, or you can write it like this one, where it's chlorine 35, like that. Either way. And then let's see, 29 is copper. So fill in this stuff here. 29 plus 34 is 63. So Cu 63. Okay, this isotope that I gave, how many protons does it have? If you look at that bottom left number, so it's 5, 5, 5. The amount of neutrons that it has, you take 12 minus 5, which is 7. And then the mass number is 12. I think you guys were getting that stuff pretty good. If you have any questions on that stuff, of course, let me know. Chapter 9, some vocabulary that you need to remember from that. Atoms, molecules. This was the chapter that we went over chemical reactions. We have some chemical equations. So just remember with chemical equation that it's like reactants, yields, that's this arrow, and then products. Okay, and then we're supposed to fill in the table, which again I didn't write and wrote some of this stuff, but I guess I didn't realize that I needed to write more. Oh well. All right, so let me get my periodic table again. The periodic table that I got is tiny on my phone. Okay, let's do an easy one at first. Sodium and fluorine. So if we were going to do the electron dot notation to figure out the formula, we would do something like this. So remember, Na would have 1 valence or outer electron because it's in that first group. Fluorine would have 7 because it's a halogen. So this would want to go over there like that, which would end up making it like this, right? The formula isn't that. What's the formula if you do the crossover technique? It would be NaF. Okay? So let's do calcium and oxygen. Another easy-ish one. So we have calcium, which is 2, and oxygen, which is 6. And how many electrons do they want to have on the outside? If you remember, they want to acquire that octet rule, so 8 outer electrons, so that makes that Ca2 plus. And then when you add the 2 electrons, it makes this oxygen 2 negative. So if you do the crossover, it's Ca2O2, but remember with ionic, you want to reduce it. So it's just CaO. Okay, let's do aluminum and sulfur. All right, so aluminum has 3, sulfur has 6. All right, so 2 of these will go like this, but then you've still got one. So you got to add another one, which now you only have 1, so you're going to have to add another aluminum. I didn't give you guys enough space for this. So you have 2 more here, so you need another sulfur. So you end up with, this is terrible, you end up with Al, and how many did you have to use? You had to use 2 of those, right? And then you have sulfur, and you had to use 3 of those. So that would be the formula for that. And let's see, let's do another one. Let's do beryllium and chlorine. So beryllium, there's 2. Chlorine has 7. So it gets 1 of those, and then you need another one. So you have BeCl2. So if I say something about doing the electron dot in order to find the formula, unfortunately, you'll have to do it like this, guys. Sorry. Okay. All right. So then it wants us to name these compounds. So this is one of those, this is one of those that we're going to want our reference page again. Nope. Let's see, go back to files here. And okay, it's really tiny. This is the one that you're going to want for, you're going to want to look at table 9.2 and 9.3 for this. So the CU, the CUS, if you look at this table 9.2, see this CU right here? It's for copper. It can be +1 or +2. So how do you know if it's +1 or +2? We'll see this formula. Go over to sulfur on your periodic table. And what would its ion be? Well, it would be 2 negative. Well, if it's CUS, then that means that this had to be Cu2 positive. So when you go to name it, it would be copper 2 sulfide. So if it's something found in that table 9.2, then you have to use like the Roman numerals in order to, you'll have to use Roman numerals in order to name it. Sorry, my daughter just walked in. Emma, go on. I gotta keep doing my recording. You can't, baby. Go on. I'll be out there in a minute. Okay, sorry about that. And then chromium is the same way. You have to figure out which one it is. Well, you know oxygen is 2 negative, so since it's just CRO like that, it has to be like this, right? So it's chromium 2 oxide. Right, then I gave the name of some. I said carbon tetrachloride. Well, if it has these prefixes like this, that tells you that you're probably dealing with a covalent compound, right? So tetra being 4, so it's CCl4. And then diarsenic pentafluoride. So di meaning how many arsenics. So you would have 2 arsenics here. Sorry, I was like walking and trying to write at the same time. It's not easy. Pentafluoride, so arsenic pentafluoride. Okay, then I threw another type of situation that we had where if you count the total elements here, you see that you have 3. Well, so that should tell you that you're dealing with something over here in table 9.3, the polyatomic ions. So when you go to name this one, it will be calcium. You just name the metal, and then you look over here on the polyatomic ion table, and that SO4 is sulfate. So just calcium sulfate. All right, and then you've got sodium, so Na plus, right? Hydroxide. So again, if you look on the periodic table, you won't find hydroxide. It's one of these polyatomic ions, which hydroxide is just OH negative. So if you do the crossover thing, it's just NaOH. NaF is just sodium fluoride. And then if it gives you one with a Roman numeral, then you have to use the Roman numeral to tell you if it's +3 or +2 or whatever. So the Roman numeral 3, obviously +3. Phosphate ends in 8. So that means you got to go over here to this table, which is 3 negative. So you have PbPO4. So, like that. All right, hopefully that is making sense, guys. And this one, you would have to use this table, this orange table right here. So silicon is 1.8 and oxygen is 3.5. So if you take 3.5 minus 1.8, you get 1.7. So if you look at this table, if it's 1.7 or greater, then that means it's an ionic. Okay, oxygen is 3.5, so 3.5 minus 3.5 is 0, so covalent. H is 2.1 and tellurium is, let me find it, 2.1. Yep. So 0 again. I didn't give you a very good one for polar, did I? Let's say I did hydrogen and oxygen. Hydrogen's 2.1, oxygen is 3.5. So if you do 3.5 minus 2.1, then you get 1.4, which if you look at this table, between 0.5 and 1.7 is polar covalent. So there is a situation that would involve that. All right, I think I'm gonna have to do another video for chapter 10. So anyway, I'll get that done and get it up there as well.